Hi, this is Kevin Trainer. Welcome to my tutorial demo. This one is associated with Chapter 8 of the Murach MySQL book, second edition, and this is the chapter on data types. Typically, in the tutorial demos I've done so far, I've tried to do some exercises that are going to be like the ones that I've assigned for homework. But in Chapter 8, the exercises are pretty straightforward, and I think you're going to do fine on your own. And there are some issues that come up in Chapter 8 that I think are pretty important, and they kind of get us ready for designing databases, which we're going to do in a couple of more chapters. And here is, I think, a nice opportunity to take some time and try to get at what the best practices are in relational databases. If you remember when I was doing the lecture, when I came to slides 13 and 14, and they talked about the enum and the set types, I said I thought these were very cool types. But I wasn't going to recommend them because one, that their implementation was very MySQL specific, and I was going to recommend that you use proprietary features when you could avoid them. And then the other one is that I thought that they went against the sort of spirit of relational databases. And that's the part, the latter part. What is the spirit of relational databases, and what do I mean by that? That I would like to talk about here. So here we're going to talk about the enums first. So we have these values: yes, no, maybe, possibly. So what are these the answers to? Well, they're answers to some question. So I'm imagining that we have a questionnaire. So we're not going to be looking at this in a vacuum. I said to myself, well, let's design a questionnaire application, and let's see how we would treat these in sort of a naive design that didn't really take full advantage of the relational features. And then what we're going to do is we'll spend a minute or two saying how the enum could help you. But I don't want to give the enum a lot of airtime because I want to go on very quickly and talk about how we would do this in a proper relational database design. Okay, so here, these are answers to some kind of a question on a questionnaire. It looks like when we say we have an enum of yes, no, and maybe, it means that the controlled values that are allowed are yes, no, and maybe. And it's the nature of enums that we can put in other responses, but the responses are not recorded. They're recorded as empty string. Okay, so these are, so we're controlling values kind of. Okay, so let's compare this with my first version of the design of a questionnaire, which I call the naive version. And this is how somebody would do it if they didn't really have all the nuances of a relational database design down. Okay. So first of all, we have what kind of diagram are we looking at? We're looking at an entity relationship diagram. What tool did I use to create it? I used Visual Paradigm Community Edition. This is a tool that I've used off and on for a number of years. The Community Edition is a free version, so this is a tool that you could download and use yourself, but you're not going to have to do it for this course. And I've already shown you in an entity relationship diagram that came from one of the MySQL tools, so I'm trying to show you a variety. Okay, and so, and what kind of a model is this? Well, this is probably a logical data model. Okay, somebody might say, well, because we already picked the kinds of data types we're going to use, it's even a physical data model, but it doesn't have all the details that go into a physical data model. Okay, so if we're going to have a general system here for the questionnaires, let's say we're a research center, we do questionnaires, we do them over the web, and we send email links to our potential respondents, and they log in to our questionnaire and they fill it out. Okay, so we have multiple questionnaires, we have multiple respondents. We keep the identifying information for our respondents because it's not a problem for us. There are some research situations in which you need to protect the identity of the respondents, but we're just going to simplify the problem here and say that that doesn't apply to us. So the entities in the design, which become the tables, the first one I want to talk about is the questionnaire table. So it has a primary key of questionnaire ID. It's just a plain old int. And it's got two character columns, name and description. So this is some kind of a short name of the questionnaire. I made it a varchar so we would know exactly how long the name was. And then the description is longer than that, and varchars can go up to 255 characters. So I said, well, if we need to go that long, we can go that long. Okay, so we've got multiple questionnaires. We have multiple respondents. So for each person who could be a respondent, we've got their first name, middle initial, last name. Okay, and we also have a respondent ID. So the respondent ID is the primary key. It's a plain old int. The first name is a varchar 35. Again, we want to know exactly how long that string is, and 35 is serviceable. You'll see people having first name shorter than that or longer than that, but that's in the ballpark. Middle initial is just one character long, and it's nullable. This is how this gets shown on this particular diagrammer, which means if there isn't a middle initial or we don't know the middle initial, we can enter a null, which means that they have none. The last name, another varchar 35. We have an age, which is an integer. We have a gender, and here's a case where this is not the ideal design. We made this varchar 10, okay? And this is sort of the naive approach. Somebody who is maybe new to relational databases and not so concerned about controlling values and things we're going to learn about when we get to normalization of our design. They go, well, you know, I'll either want to type in male or female. Okay? Well, that has some highs and some lows. One is that it's easy to type in. If you say it's just characters, the tools are going to allow you to type in some combination of characters. The problem is that you're not controlling the values. So even within the two values, male and female, there are a lot of combinations of uppercase and lowercase that could be different from each other. And so when you wanted to use this column for queries, you'd have the problem that you don't have controlled values in the gender column. Okay, but let's say we're rookies and this is what we do. And then we also might want to know some other demographic thing like their annual income in thousands of dollars. So that's an integer. So I would say the only naive thing that we've done here so far is the type that we picked for gender and the design there. Apart from that, I think we're doing fine. Okay, so each questionnaire has 0 or more questions. Okay. And I just want to say that in this case, we don't expect to share questions. So the primary key of the question is the questionnaire ID plus a question ID. And again, for these IDs, we're just using plain old integers. So you can see that the questionnaire ID is not only a part of the primary key of question, but you see this little pointing to the left green arrow. It also says, oh, this is part of a foreign key as well. Well, what is it the foreign key to? Well, it's the foreign key to the questionnaire table. Okay, so if we're going to have a questionnaire ID that we place in a question, it has to correspond with an actual row in the questionnaire table. And we're going to make sure that happens when we learn how to do this by creating a foreign key constraint. The question ID is just a plain old int. We haven't said it here, but maybe we would have the question ID be one of those auto increment fields. We could have done that for the questionnaire ID field too. The stem in the quiz business, or the questionnaire business, certainly the quiz business, the question itself is called the stem, and the possible answers are called the responses. So that's why I called it STEM. I worked on a quiz application within the last year, and that term kind of stuck with me. Although for research questionnaires, it's probably the wrong term. But it seems kind of techy. And I wasn't sure how long the question would be, so I just said it's the longest of the varchars that it could be, up to 255 characters long. Okay, so that's that. Now, here's a part of the design that you've already seen, okay, because you've seen it in the My Guitar Shop database. What happens when you have between two tables, there's a many-to-many relationship. So each question has many respondents, and each respondents can have many questions. Well, it turns out in relational databases, we don't create the construct directly, because relational databases don't have direct many-to-many relationships. What we have to do is we have to create an intermediate entity or table that we call an associative entity, or an associative table. And so this is each response is for a questionnaire ID, and for a question ID, and for respondent ID. Okay, so that's how that's how you get the many-to-many, okay, with this associative or intersection table, some people call it. And what I've done here, and here's where I've done sort of the naive thing, I've just given a varchar 20. So my thought is that we could have answers like we saw from the slide from the lecture. We could have yes, no, maybe. We couldn't have a possibly. See, the interesting thing here I'm sorry. We could have whatever we wanted because these are just simply characters, right? So yeah, we could. So we're not controlling the values here either. So this is less controlled than the version that might be done with an enum. So we've got a pretty good design here. What's especially good is this. We have this response table. Some people might call this the question underscore respondent table because it's the sort of intersection between those two. Um, and it's what implements the many-to-many relationship between questions and respondents. Okay, so that's a great design. What's naive is that we're not controlling the values for the response. And the other naive things is we're not really controlling the values for gender. Okay, so let's back up a bit here. All right, let's back up and let's look at these enum things. All right, and you can see how this starts to look appealing, and this looks appealing for both gender and response, because if we're doing a typical yes, no, maybe kind of questionnaire, well, response could be this kind of enum. And then we could have an enum for gender where we would have like male and female. Okay? Now, the problem that I have with this solution, one, is that we use a feature that's not available in all relational database products. Okay. Two, it's not very extensible. Okay. Right now, we're expecting to get yes, no, and maybe. Okay. As our possible answers. What if we decide that we want more shades? So we want to have yes, we want to have no, we want to have something that's weaker than maybe. I would say we're going to come up with a whole new, some other scale of responses. The problem that we have is that it's very hard to go back and change the design of the enum. You actually have to go change the design of the table. Now that can be done, but it might take some conversion, right? It's not a matter of saying, oh, we have one possible value that we've added that we haven't been using. Let's add a value to the values table. Nope. We have to go back and we have to change the definition of that table. We have to go to the column and change that. And that means that we may also need to do some conversion of the data. Okay, that seems like a mess to me. Now, here's our alternative. Our alternative is to go to what I consider to be the improved data model for questionnaire. Okay? So, what have we done? Well, some of these things are just the same, and a couple of them are different. Okay? The questionnaire table is the same. All right? The question table is the same. Okay? The respondent table is just a little different. Instead of having gender as a character field, we control the value by keeping the gender ID as a foreign key. You can see the foreign key indicator here. And that points across to a gender table, okay, that has a gender ID and a gender description. and I made the gender description about the same as I had had on the gender field when I had that as an uncontrolled field. So what happens is that if we decide that we have two genders, male and female, well, then we add those. We have male and female. We have two possible lines. Okay? They each have a gender ID. Okay? And then it turns out that all of the rows in respondent have either the gender ID is a foreign key of 1 or a foreign key of 2, say. So a lot of people would look at that and say, well, I don't really see the difference between that and what we've done in the Enum version, because we're only going to ever have two genders. And that's always the famous claim. We're only going to have so many of whatever. Okay. Now, I thought for a long time that there, by definition, there were going to be two genders. Okay. And I used to teach a data model in a class where I would use gender as an example of an attribute that had a sort of a non-varying list of possible values, by definition, male or female. And I had a person come to my class who was from a human sexuality training company. And he said, well, in our company, when we look at the world in the courseware that we create, we have about 5 genders. So we have, people who are male who identify as a male, people who are male who identify as a female, and he went on and on and on. And he said, so this wouldn't be just male or female. It would be more complex than that. It might be that when you looked at the data, probably most of the rows in the respondent table would be associated with the gender ID for male or the gender ID for female, but we would have some that would have other gender IDs. So the idea that just because you think that something has two values, that it will never have other values is, it turns out when it comes to database design, pretty short-sighted. Because what happens is that our frame of reference changes, okay? And what seems to be, a fixed length list of possible values for a long time becomes more variable than we originally thought. So the thing that I prefer in this design over the naive version and over the Enum version is that we can have just as many rows in the gender table as we need. We can start out with 2, we could expand to 3, we could go to 5, we could go to 7. Whatever's appropriate for our application, we could do. We don't have to change the definitions in the database. It all works just perfectly. Okay, so that I think is more within the spirit of how to control values in a relational database. All right, so let's look at the other thing that's different, and that is over here in response. Okay, we had not controlled the values of the response, so you could type in whatever you wanted. Well, again, that makes it a lot harder to analyze the data because, people, if you give people the opportunity to type in whatever they want, experience will show that they will type in whatever they want. So what we have here is instead of recording some kind of free-form text, which is the naive approach, what we've done here is we have a response value table, which has a list of the valid response values. And it has a response value ID, which is a typical int, and response value text, which is the description. And I wasn't sure how long that had to be, so I said that could be a varchar 255. Now, this is the same approach that I took for gender, okay? And it's going to work really well, okay? It's going to control all the values. And I know because this response value ID is a foreign key, I know that I can only record response values that are valid, okay? Let's compare that with the Enum approach, okay? If we go back and we look, if we go back and look at the Enum approach, let's find that, okay? Well, we could get yes, we could get no, we could get maybe, okay, and let's say those are our three valid values. But we could also get this fourth value. Okay, so this is, we're not really controlling the type, because so we could have a whole bunch of things. So we always get a none of the above option here. Perhaps we don't intend one, okay? Whereas in the design that I recommend, which I call the improved version for the survey, okay? If we want to have yes, no, maybe, none of the above, well then we just have 4 rows in the response value table. Okay, so we get control over how many values there are. It's sort of inherent in the enum that you don't have full control over that. So this is how we really do it in relational databases, the design that you see here. I think that the Enum is a modern shortcut that is probably not well chosen. Okay, we've talked about the enums. So let's go back and talk about the sets. Okay. Here we have a set. Okay, and this is, so I looked at this and I said, well, I think we're doing pizza ordering, okay? So the question is, on a particular pizza, what are the extras that I want on the pizza? So what I have is, I have a set, pepperoni, mushrooms, olives. So these become the only things that I can have, okay? So if somebody types in pepperoni, then I just get pepperoni. Mushrooms, I get mushrooms. Pepperoni and bacon, well, I only get pepperoni because bacon isn't allowed. Olives and pepperoni, well, I get the pepperoni and olives because they always occur in that order, and that's what that happens. So this has, it is somewhat better than the enum in that it doesn't allow non-conforming values at all. If you go back to the enum, if we had a possibly, well then we just got an empty string here. So that's really what I call a non-conforming value. Okay. Whereas here, when we have a non-conforming entry, well, we just don't get anything at all. So all the entries that we get are conforming to our controlled list. So that's a good thing. The problem that I have with the set is that it has multiple values. So when we learn about um, uh, normalizing relational database designs, we're going to find out that one of the first things that we do is that we remove repeating columns. And having a column that can hold three values is really no different. It's a little more convenient, but it's really no different than having three columns that can hold the same kind of values, right? So this breaks the rules of normalized relational database design. So it's an interesting idea, and it's newfangled, but it's because of that kind of wrong-headed. It doesn't conform with tried and true thinking about relational database design. So let's go look at pizza ordering. Okay, so let's have a really naive, pizza ordering application. So this is the kind of data that we collect when a server comes to your table and they have some kind of like standard order pad. And you've seen the pads. They're kind of beige on the top or light green and darker green down the bottom, and they have a number of lines, and they have some kind of serial number on them and all that kind of stuff. And there's a box for table, there's a box for server, and they put in some kind of number. And do they put the date in? Do they put an order ID in? Well, we can imagine that they do. But what happens when they write the order? Well, they just write on the paper. They just write, there are lines there, but they just write and write and write and write. And the people in the kitchen have to come to understand what they write. And sometimes people are good at that in the kitchen, and sometimes they're not. And do we control the values? No, we really don't control the values of, say, what table this is. They can put down 54, they can put down nothing at all, they can make a mistake and put down 45, whatever they put there. And the same thing for server. I mean, they can write down Linda Jones, they can write down Linda, they can write down Squeaky, which is the nickname for Linda. They can write down whatever they want because there's no control over the values there at all. And then the order description, can they order things that are off the menu? Well, sure they can. They can write whatever they want on that ticket, right? So if in fact we were to take a manual pizza ordering process, all right, this is what it would look like if we turned it into a design for a relational database. It wouldn't be very sophisticated at all. Okay, I'll admit that this is a lot worse than something in which we would use the enum. Now I want to show you an improved design for the pizza ordering system. This is a typical relational database design. And I will walk you through it. So the order itself still has a primary key of date and order ID. Those make sense. There's a table ID. There's a server ID. Okay. I've gotten too far. Oh, yeah. So there's a table ID, there's a server ID. These are foreign keys that point into the table, and the first use of the word table, I mean a table or booth. And the server is the wait person, okay? Now, somehow I accidentally left this order description here. Pay no attention to the man behind the curtain. This is not supposed to be here. So just sort of imagine that this completely went away, okay? All right, we're just going to leave that shaded there. So what is on the order? Well, we can order items, okay? And an item is this is a pizza restaurant, so an item could be a large pizza, a medium pizza, a small pizza, an extra large pizza, something like that. Okay. Um, so uh, we have these order lines, right? And this is a pretty crude system, but um, what is on the order line? Well, each order has one-to-many order lines. Okay. Um, its a primary key is a combination of the date, the order ID, and the line number. And I see I have to improve this yet. I apologize for that. I should have the little keys there, right? Um, whenever you create new courseware, you have to vet it out, I guess. So the primary key is made up of those three columns: date, order ID, line number, and one piece of data, item ID. So if you order three medium pizzas, you have three line numbers. Okay, and if let's say we ordered a medium pizza, a large pizza, and an extra large pizza, we would point at three different items in the item table: item ID and description. Okay, so there is a many-to-many relationship between order and item. In this case, the item being some kind of pizza. You will notice that I don't have quantity here. Okay, and that just kind of comes from my pizza days. If somebody's going to order two pizzas, I'd like to see two lines on the order. If they're going to order four pizzas, I'd like to see four lines on the order. And this is because I was a pizza maker and worked in a kitchen at a pizza place. Could you have a quantity where you could have just one thing that you're ordering and say you want 15 of them? Sure, you could. It's just I wasn't really thinking that way. Now, how are we going to take care of the pepperoni and the mushroom and the anchovies and all that kind of stuff? I'm saying we're going to do it with these things called extras. Okay? So each order line, okay, has from 0 to many order line extras. Okay? So what's the key of the order line extra? Well, it is the date, the order ID, the line number, and the extra ID. And I see here I need some more primary key indicators here. So these are going to need a little bit of work. And this, what are the rows like in the extra table? They would have values like pepperoni, sausage, mushroom, onions, green peppers, anchovies. So if we had one order, right? Somebody ordered one medium pizza. Okay, so we'd have one order, we'd have one order line. It would be connected to one item, a medium pizza. If in fact we had three extras on it, we would have three order line extras, and one would point to sausage, one would point to mushrooms, one would point to onions. Now, when you go out to a modern fancy pizza place, and you see typically when they take your order, they use one of those little green pads or some kind of a notepad. But when you get your bill, you can often see that what you have is this kind of data on your check. Okay, so you have an order line for each of the pizzas, and underneath that, you typically have sort of indented in italic or something like that, like add sausage, add mushroom, add onion. And this is how they do it. This is a data model that makes that go. Now, the thing that I like about this is the list of extras that we're going to have at my pizza restaurant is pretty volatile, okay? It's going to change over time, having to do with the taste of people in my particular area. I remember the days when there weren't a lot of places where you could get ham and pineapple, as the Hawaiians liked, but over time, those come to be fairly common things that you could get. I would imagine that there's some place that you could get coconut. I would imagine that there's some place that you could get lobster. Okay. Now, I don't think that we want to rely on something that's pretty fixed, like an enumeration that is in the definition of the database column to control the values. Having the values controlled by having a table of valid values is much more flexible. It can be updated by the users. Okay, the users can have a transaction where they add more possible extras to the list of extras, and maybe if nobody is ordering anchovies anymore, they can take anchovies off because they're not going to carry them, and they're not mucking around with the definitions of the database. So what I've tried to do here, and I apologize that some of the graphics here are a little bit young and not perfect, but what I try to do here is to say, I don't like those two features. I don't recommend that you use the enum. I don't recommend that you use the set. We have the same problem with the set that we have with the enum, in that it's not easily maintainable by the users. You have to consult the programmers to change your list of extras. That sounds like a bad idea. Okay. The same thing with the enum. You'd have to consult your programmers to decide how many genders you want to have in your system. Not such a hardship because you wouldn't be changing your mind about that all the time, but certainly something that you might want to have under user control. So this is the spirit of relational database design. It turns out that the number of character fields that you're going to have where you're not going to constrain the values is going to be pretty small. Okay? And these kind of tables that are essentially a list of valid values, these are all over a properly designed relational database. So I'm going to leave you to think about this, and I'm going to say bye until next time. Bye-bye.